the triple integration is one mode. That is, what is that? Z. Okay. So like in the double integration, we have what is that? Dx and dy. Okay, no? So now in the triple integration, we have to write what is it? Dx, dy, and next what is it? Dz. So that's we are writing here. This is nothing to dv. Okay, and this is dA area. Dx, dy, and this is dx, dy, dz, that is dv. Okay, now the triple integration. Okay. So this is a triple integration. Okay. Now, let's see the one problem. So here we have to remember one thing. So when you are doing the integration with Z, okay. So when you are doing the integration with respect to Z, okay, then x comma y are become constant. Okay. So now when you are doing the integration with y, okay, then x comma z are constant. Next, when you do the integration with x, then y comma z are the constant. Okay, so keep in mind, so when you are doing the integration with z, the variables are x comma y, or we are taking to the constants. So when you are doing the integration with respect to y, the variables that x comma z are become the constant. We are taking as a constant, and when you are doing the integration with x, then y comma z are become to the constant. Okay, now let's see one problem here. So evaluate the triple integration 0 to 1, 1 to 2, 2 to 3, that is x, y, z, dx, dy, dz. Okay. So first we are doing the integration with the x. Okay. So that is x dx is become what is that? X square by 2. So these are the x limits. So first dx is, so these are the x limit, and these are the y limits, and these are the z limits. So like this, we can write that x dx is nothing to what is that? Integration of x dx is x squared by 2. So the limits are 2 to 3. Okay, then we are applying to the limits. Then we are getting 9 by 2 minus 4 by 2. That is nothing to 5 by 2. So that 5 by 2 we are writing to the outside. So next we have to do the integration y dy. So y dy is nothing to what is that? Y squared by 2, and applied to the y limits are 1 to 2. Okay. So when you are applying to the limits of 1 to 2, that we are getting 4 by 2 minus 1 by 2 of z, that is become 15 by 4, and 0 to 1 z dz. So after that at the end, then we are doing that z dz. So z dz integration is z squared by 2. So now you can apply the limits 0 to 1. So when you're applying to the limit 0 to 1, and we are getting the answer 15 by 8. Okay. So this is a triple integration. So it is very important for the short answers when you are writing to the final examination theory. Double integration formulas and triple integration problems. So both are important. So here remember one thing. So this is dx, no? So dx, this is the x limits, dy, that is the second, and dz, that is the here. So these are the limits of evaluated of the triple integration. Okay, next see here one more one. Ah, so here evaluate 0 to 1, y square to 1, and 0 to 1 minus x dy dx dz. Okay, so remember one thing here, how we can know that are the x limits, how we can know these are the y limits, and how we can know these are the z limits. See, observe, you have to, if you are observe the limits, so if you are observe to the limits 0 to 1 minus x and y square to 1, okay. Uh, so you remember one thing, they are giving dy, next they are giving dx, and next they are giving the dz. So first we are doing the integration with the dz. So that is become x into dz, that is become z. So now apply the limit 0 to 1 minus x and dy dx. So first we have to, in place of z, we have to take 1 minus x minus 0. So that is become 1 minus x dy dx. Now that we can write 0 to 1 and y square to 1, x minus x square into dy dx. Now again, here the limits are, what is that? Y square to 1. So if we are doing it with dy, so we cannot applicable to that y square and 1 limits. So that's why we are doing the integration with dx. So when you are doing the integration with dx, so that is become, what is that? X square by 2 minus x cube by 3, and apply the limits 1 to y square. Okay, this is the thing. So after the simplification, and we got this thing, no? Now we have to do the integration with y. So that is become 1 by 6 into y minus 1 by 2 into y power of 5 by 5 plus 1 by 3 into y power of 7 by 7 and 0 to 1. Okay, so now apply the limits. Upper limit is 1 and the lower limit is 0. Then we are getting, what is that? 1 by 6 minus 1 by 0 plus 1 by 25. So that equal to 4 by 35. So here you can take this 0 to 1 minus x as z limits or y limits. That's your choice. And here also y square to 1. So y square to 1 also you can choose as the x limits, and you can choose for the z limits. Okay. So that's your the wish. Okay. If we are taking that y square 1, so we cannot take for this is for y limits. So 0 to 1 minus x. So we cannot take the limits for x. Okay. So this is a important things, that is uh, here one more important problem is there here. So evaluate the triple integration of x square plus y square plus z square dx dy dz, where v is the volume of the cube that bounded by the coordinate planes x equal to y equal to z equal to a. Okay. Now that all the x, y, z, that is all the x, y, z equal to a, that become, what is that? The x limits are 0 to a and the y limits are 0 to a and the z limits are, and that is 0 to a. Okay. So this is the things we can write that x, y, z equal to a, that is the plane. So here the limits are x comma y comma z is various from 0 to a, 0 to a, 0 to a. So x square plus y square plus z square into dx, dy, dz. Okay. Now, first we have to do the integration with z. Okay. So when you are doing the z, then we are getting x square z. Next, this is become y square z. And this is z square is become what is that? Z cube by 3. Now apply the limits of 0 to a. So that is become x square a plus y square a plus a cube by 3 dx dy. Okay. Next, we have to do integration with y. So when you are doing the integration with y, that is become x square ay plus ay cube by 3 plus a cube by 3 into y, and the limits are 0 to a into dx. Now at the last, we have to do the integration with the x. So that is become x cube by 3. Next, this is become a power of 4 by 3 into x. Next, that is become a power of 4 into x. Now apply the to the limits 0 to a. So that is become a power of 5 by 3 and a power of 5 by 3, and that is a power of 5 by 3. So that is nothing to 3 a power of 5 by 3. The 3 get cancelled and we are getting a power of 5. Okay, this is the things. Okay, now we should, yeah, now here, so here the one more problem is there. So evaluate that is x equal to 0 to 1, y equal to 0 to 2, and z equal to 1 to 2, and x square y dz dx dy dz. Now for this one, see, listen here. So first we have to do the integration with z. So this both will be constant. What are the constant here? X square y, and into the limits are z equal to 1 to 2. What we are getting? Z dz. So the double integration of x square y z square y to 1 to 2. So that is 4 by 2. 2 minus 1 by 2. After that, again, we have to do the integration with y. So if you are doing the integration with y, same procedure. So first we have to do the integration with z. After that, we have to do integration with y. And after that, we have to do the integration with x. So then we are getting that. Okay. So before that, we have the two things, that is dx and dy. So we are changing in the variables, that is r dr d theta. So here also in the triple integration, we have dx, dy, and next dz. Okay. Now this we have to do change of variables. So remember one thing here, that dx, dy, dz. If x is a function of UVW and y is a function of the UVW and z is a function of the UVW, how we can change that x, y, z in terms of UVW means, so this is the things. Here the Jacobian. So what is the Jacobian means? The determinant of the partial derivatives of first order differential equations. So you just remember one thing. Just you should remember one thing, that dx, dy, dz equal to, that is become r square sine theta into dr d theta d phi. So remember here one thing. So dx, dy, dz. So that equal to r square sine theta dr d theta d. So that is become r power of 4 sine theta dr d theta d phi. So then we are getting r power of 5 by 5 and 0 to 1 sine theta d theta d phi. So when you are doing the integration with sine theta integration is minus cos theta, and you should apply the theta limit 0 to pi. So at the end of we have to write d pi. So that we are getting what is that? 4 by 5. So this is that. Now the most important task is, so where we can use that multiple integral, either double integration, either triple integration. Okay. So how we can use that application means, so where we can use that integrals. The application means where it is useful for the integrations. Okay. Now, so find the area of the region bounded by the parabolas. Y square equal to 4ax and x square equal to 4ay. Okay. Now the given curves are y square equal to 4x and x square equal to 4a. So now if you are simplify these two, okay, from these two equations, that we are getting what is that? If we are squaring on both sides, then we are getting x power of 4 into 16 a square y square. But y square equal to 4ax, no? So now you can substitute that y square equal to 4ax. So that is become what is that? X power of 4, 64a cube x. So after the simplification, and we are getting what is that? X equal to 0 and x equal to 4a. So when x equal to 0, then automatically that y equal to also become also 0. So here is that. So y square equal to 4a into 0. So y square equal to 0. That y equal to also 0. Next, when x equal to 4a. So if we are substituting that x equal to 4a, and we are getting y equal to also 4a. Okay. Okay, now these are that. Now the curve is intersecting at the origin 0, comma 0, and the curve is intersecting 4a, comma 4a. So the area is become integration of dx dy. So, okay, the region R can be covered by various from x from the upper curve, x equal to y squared by 4a to x equal to 2 root a, and the y is various from 0 to 4a. So we are taking that y equal to 0 to 4a and x equal to y squared by 4a and 2 into root ay. Okay. Now, now we have to do the integration with dx, and we are getting in x dx. Yeah. So this is the thing. So in the same way, so we have to solve that x square equal to y and y square equal to x. So how we can write, man, see this, x square equal to y and y square equal to x. Okay. Now from this two, how we can write means, this we can write x power of 4 equal to y square from this one. So x power of 4 equal to y square equal to what is that, x. From there we can find the limits of x and limits of the y. So from we can write that thing. Okay. Now see here. See, ma, this is also very important. This one, the very important problem. Find the volume of the tetrahedron bounded by the plane x by a plus y by b plus z by c equal to 1 and the coordinate planes. The solution is x by a plus y by b plus z by c equal to 1. The given that the condition x by a plus y by b plus z by c equal to 1. So next, so from here we can write the z equal to. So how we can write the z equal to means, so z by c equal to, we can write 1 minus x by a minus y by b. So z equal to c into 1 minus x by a minus y by b. Okay. Then if f of x comma y is continuous and singular function, then we are getting this. Now the volume of the region. So z into dx dy. So z into dx dy, no? So z means what is that? C into 1 minus x by a minus y by b and dx dy. So the equation of the intersection of the given surfaces, that is x by a plus y by b equal to 1, no? The limits are y is become C here. So from here also we can write y by b equal to 1 minus x by a. So that y equal to is become b into 1 minus x by a. So these are the y limits. Okay. Then after you have to substitute here. So the x limits are 0 to a, then the y limits are 0 to b into 1 minus x by a. So now first we have to do the integration with y. So 1 into dy is become y and x by a into dy equal to x by y by a. Okay. Next that is y by is become what is that, y squared by 2b and 0 to b into 1 minus x by, and c into then apply the limits. So when you are applying to the limits, then we are getting the after the simplification. So this is only just the simplification part. Okay. Now again we have to do with the integration with. So that is become 1 by 2 into x minus x square by 2a plus x cube by 6a square, and the limits are is become 0 to a. So at the end of after the simplification, and we are getting that ABC by 6. Okay. So this is that important problem, very important problem. This is very important problem for your examination point of view. Okay, next. Next, one more problem. Find the volume bounded by the cylinder x square plus y square equal to 4 and the plane y plus z equal to 4 and z equal to 0. So from here we can write the z equal to. So z equal to we can write 4 minus y. So is to be integrated over the circle x square plus y square equal to 4. So from here then x square equal to we can write what is that? 4 minus y square. Then x equal to the plus or minus under root of 4 minus y square. Okay. Then plus and plus or minus, then we can write that. Next. So this is the x limits and these are the y limits. These are the y limits and these are the x limits. So when we can say that y varies is minus 2 to 0 means, so here we have to substitute 0. So x square plus 0 equal to 4. That is become x equal to plus or minus 2. Then x equal to minus 2. Then x equal to plus 2. So this is that. No. So first we are doing the z dy. Okay. So that we are getting that z dy. Z means what is that here they given 4 minus y. So 4 minus y into dy dx. So initially first we have to do the integration with dx. So 1 into dx is the limits are that 0 to 4 under root of 4 minus y square into dx. So under root of 4 minus y square into dx, that limits we can apply that we are getting under root of 4 minus y square. Now we have to simplify. 4 into under root of 4 minus y square minus 2 to 2 y into under root of 4 minus y square. So since this value is going to 0, why? Because it is an odd function. Why? Because this is 2 and this is the minus 2. So automatically that is become 0. Now for this one and the intermediate level we have the one formula. So under root of a square minus x square into dx. So that is become what is the formula? That is x by 2 under root of a square minus x square plus a by 2. That is a square by 2 and sine inverse x by a. So using that formula and we are getting. Now apply the limits. What is the limits? Minus 2 to 2. So when you are applying to the minus 2 to 2, then we are getting that minus 16 by 5. Now, the application of triple integration. So the application of triple integration, the values dv is become dx, dy, dz. So where the integration is carried over the entire the value. So now you can write that find the volume common to the cylinders x square plus y square equal to a square and x square plus z square equal to a square. So x square plus y square equal to a square means then we are getting y square equal to a square minus x square. Then y is become plus or minus under root of a square minus x square. Next x square plus z square equal to a square. Then we are getting z square equal to a square minus x square and z equal to the plus or minus a square minus x square. So therefore the limits of z is from under root of a square minus x square to the root of a square minus x square. This is minus and this is the plus. And in the same way, the y is also is become minus of under root of a square minus x square to under root of a square minus x square. So the limits of x is from minus a to a. So therefore, the value e equal to integration of minus a to a and integration of minus of under root of a square minus x square under root of a square minus x square, and that is also minus of under root of a square minus x square and a square minus x square dz dy dx. Now you can, that is integration of 0 to a and 0 to under root of a square minus x square and 0 to a under root of a square minus x square dz dy dx. So this is, so first we have to do the integration with z. So z means 1 into dz is z and apply the limits 0 to under root of a square minus x square. So you can write under root of a square minus x square dy dx. Next to that we can write y. So that is 0 to under root of a square minus x square. So after that we are getting under root of a square minus x square into dx. Now you have to do the integration, that is a square into x minus x cube by 3. Here that we are getting, what is that? A square x minus x cube by 3. The limits are 0 to a. So that is become a cube minus a cube by 3. So outside that 8 is there. That we are getting 16 a cube by 3. So these are the cube units. 16 a cube by 3 is, that are the cube units. Then we can find. Okay. So this is the volume of the, In the same way, here also we can do the same thing here. So polar coordinates of the sphere, x square plus y square plus z square equal to 0. So here polar coordinate means that we can write x equal to r sin theta cos phi and y equal to r sin theta sin phi and z equal to r cos theta. So this is the polar coordinates of the sphere. So remember that thing. For the circle, x equal to r cos theta and y equal to r sin theta. Now for this one, this is the part thing.